So hello everyone, let's start by looking at the error bars. Go to Graphs, Legacy Dialogs, Error Bar. Click on Simple and click on Summaries of Separate Variables. Take both cloak and no cloak to the error bars and click OK. In this graph you can see that the error bars include both sources of variations, the between percent differences and the within percent differences. So now we will be removing between percent variation. So to do that, the first step is to calculate mean for each participant. Go to transform, compute variables, enter name mean into box labeled target variable, and then in the list labeled function group, select statistical, and then in the list labeled functions and special variables, select mean. Transfer this command to the command area by double clicking. It appears on the command area as mean what, where you should replace them with no cloak and cloak. After doing this, you need to access the descriptives command by selecting Analyze, Descriptive Statistics, Descriptives. Then use the options dialog box to specify only the mean. If you run this analysis output, as you can see, the average of this variable is the grand mean, and you can see from the summary table that its value is 4.375. So now after this, we will calculate the adjustment factor. When looking at the variable mean, we can notice that the values for each participant are different, meaning that some people were more mischievous than others across the conditions. These differences in natural mischievousness contaminate the error bar graphs, which is why if we don't adjust the values that we plot, we will get the same graph as if an independent design has been used. Loftus and Mason 1994 argue that to eliminate this contamination, we should equalize the means between participants. To do this, we need to calculate an adjustment factor by subtracting each participant's mean score from the grand mean. To do this, go to Transform, Compute Variable, and give the target variable name adjustment. And then use command 4.375 minus mean. In the adjustment column, you'll notice that some of the values are positive, and these are participants who were less mischievous than average. Other participants with negative adjustment values were more mischievous than average. We can now use these as adjustment values to eliminate the between subjects differences in mischief. Now let's create adjusted values for each variables. Now that we have adjustment scores, this can be used to adjust the existing scores for each participant. First, we will adjust the scores in the no cloak condition. Use the compute command to make the adjustment. Name the new variable no cloak adjusted. Label the variable as no cloak condition adjusted values. Then double click the no underscore cloak, hit plus and double click adjustment. Do the same for cloak underscore adjusted, labeling the variable as cloak condition adjusted values, although this is optional. These variables represent the mischief experienced in each condition, adjusted so as to eliminate any between subject differences. This is proven when we create variable mean2, which is the average of no cloak adjusted and cloak adjusted. We can see in mean2 that the result will mean2 will result in a value of 4.375, which is grand mean that we calculated, which means that between subjects variability in means is gone. Now let's create an error bar chart of the mean of adjusted value we just made. And we can see that although the mean is the same, error bars have reduced. The error bars now reflect only the within person variability, which is what actually matters in a repeated measures design.